Good afternoon, guys. And today our topic is two-port network. I think you all know this two-port network, but uh, today we start in and just recalling these things. You know, any network may be represented schematically by a rectangular box, and with this two-port, one port is input and another port is output. So this is called the two-port network. Where it is required, generally two-port network is required for the transmission line, ABCD parameter, and the electronic circuit mainly. And that's why this two-port network is very much required, because in a network circuit where is the electronics components are used, we don't specify the system where the impedance is occurring, where the admittance is high, etc. And we can't define the parameter exactly point to point. But if we represent this two-port network, this device, then it became very much easy, and exactly we can analyze its performance. That's why two-port network is required. So for definition, we can for some features we have to remember this, because so many examination they are asking some questions, and this is this type. So first is, what is a two-port network? So any network any network may be represented schematically rectangular box. Okay, this is the first features. Then a network may be used for representing either source or the load. Source and load. Okay, source or the load. Uh, or for variety of purpose. Okay, next is, look, this is your two-port network. Okay, this is incoming current, that is I1, and that is also I2 incoming, and from here outgoing, from here outgoing. Okay, so it is given by +1, that is given by -1, that is given by +2, that is given by -2, and this is the voltage that is assigned as V2. This is the voltage, it is assigned as V1. Okay, this is the representation of the two-port network. I think you all know this, but just recall this. So a pair of terminal are used. Pair 1 and 2, this is the one pair, and 2 and plus minus 2, this is another pair. So a pair of either enter or leave a network. Okay, and this is called a port. Sorry. Okay, so a port is defined as, so a port is defined as any pair of any pair of terminals into which energy is supplied. Energy is supplied, or or from which energy is withdrawn. Withdrawn. Or where the network variable may be measured. May be measured. Okay. So this is a two-port network, and such a building blocks, you can see building blocks is common in the electronics. Where is the application? First is where the application is there. First application is that such a building block is very common where, that is, the application is electronic system, electronics communication system, transmission system, and the distribution system. So this two-port network, so this two-port network applicable in electronic system, communication system, next is transmission system, third in distribution system, etc. This is the application. Okay. Now, what is the another features? That is if no sources are existed in this network, then it is called the passive network or the passive port. Passive port. What are the example? Examples are transmission line, transformer, etc. Okay. And next point is if there is a network where some voltage sources or the current sources are available, then this is called the active network. Okay. If any two-port network containing branches are called active network, or active port. Okay. And now the specific construction. First, and current the two port. Okay. First one is input port First one is input port. Okay, so V1 and I1, this is the input port, and output port, that is V2 and I2. Okay, and now just remember I1, that is I2, that is V1, that is V2. Okay, so this is 1 and this is plus 1, this is minus 1, this is plus 2, that is minus 2. So V1 and I1 for this input port, and that is the output port, and I1 entering in this one and I2 entering in this 2. Okay, and V1 and V2 are the dependent variable. Now this is the question, which one is the dependent variable? So V1 and V2 is the dependent variable, and I1 and I2 are the independent variable. Okay. Okay, so this is the construction of this two-port network. Now, first we are going for the jet parameter. Okay, there is the fourth type of network, that is uh, uh, jet. This is the jet parameter, Y parameter, ABCT parameter, RH parameter. Okay, and another is G parameter, but this is not your included syllabus. But we are going for the Z parameter, then Y parameter, then hybrid parameter means H parameter, and last one is ABCD parameter. So first one is called the open circuit impedance parameter. Okay. So V1 and V2 are the dependent variable, and the I1 and I2 are the independent variable. So V1 and V2 are called dependent variable, and I1 and I2 are the independent variables. Okay. So the voltage at port 1 and 1 dashed is response produced by I2. Thus, V1 is the Z11 I1 plus Z12 I2. Okay, and V2 is Z21, this is 21 I2 plus Z22 I2. Okay, so we can arrange it just like this: Z11, Z21, Z12, and Z22. This is called the Z parameter, and each elements are called the functions of this parameter. This is called impedance parameter, Z parameter, and this is called network function. It is called network function. So this is the parameter. Okay. So we have to find out each parameter one by one. This is Z11, V1 by I1 when this I2 is 0. I2 is 0 means when V2 terminal is open, and Z11 is the driving point of impedance at the port 1 dash with the when this port 2 dash is open. Okay. Okay, and this is called open circuit input impedance. Each and everything has a special name. This is called open circuit input impedance. Okay, so Z11 is called open circuit input impedance. Okay, then we are coming, that is Z21, that is V2 and I2. So I2 is, as previous, it is 0, and Z21 is the transfer impedance. At port 1 and 1 dash, with 2 and 2 dash open. Okay, so this is called open circuit forward transfer impedance. Okay, so when V2 terminal is open, and now we have to measure the other parameter, just like Z12 and Z22. So if we want to measure this, then we have to open the V1 terminal, this input terminal. So open. Okay, and this is called open circuit reverse transfer impedance. Okay, now next element is Z22. Z22 is V2 by I2, where I1 is 0, I1 is 0, and this Z12 is called open circuit driving point impedance. Okay, and this is called so this is the network functions of Z parameter, and we have to go for the equivalent circuit. Okay. Okay. So if the network under the study is reciprocal or the bilateral, then in accordance with the reciprocity theorem, we can say that V2 by I1 when I2 is equal to 0 equal to I1 by I2 when I1 is 0, or you can say that is Z21 equal to Z12. Okay, so if you write down these things, then V2 by I1 when I2 equal to 0 is equal to I1 by I2 equal to I1 equal to 0 when I1 equal to 0. Okay, means it means 2 1 equal to Z12. Okay, so transfer admittance, transfer impedance is equal for forward and the reverse both. And now one question is that why Z parameter is called the open circuit impedance parameter? This is the question to all of you. Why Z parameter is called open circuit impedance parameter? So in this, what is the answer? Anyone can tell me? So the answer is in this two-port network, look, everything is determined as impedance, means V by I. Look, Z11 is, this is also coming from the V1 by V2, V1 by I1. Okay, so everything is coming by the voltage by the current. So this is the impedance, and that's why this is the impedance parameter. And why this is open circuit? Because whenever one parameter is going to define, then the other, any one port should be the zero or the open. So that's why it is called open circuit impedance parameter. Okay, so this is the main impedance parameter of the two-port network. And guys, if you have any question, you may ask me. Then we have to go for a numerical so that we can understand this Z parameter clearly. Okay, so I am going to stop here.